Okay, we're taking a look at problem 4, chapter 4, this little truss. We have a lot of symmetry going on. We got 3 meters here, 3 meters here, and it's 3 meters high. Got a external reaction here, 20 kilonewtons, and an external reaction here of 5 kilonewtons. Pin and roller. This is a roller. I'm going to indicate it up. I'm going to call that RDV. And we have a pin over here. This will be our AH, RAV. Okay, and we've got joints. This is joint B, joint C, joint D, and joint A. So we'll solve our reactions first. Sum of forces in the X. So in the X, we're going to have our AH, and it looks like 20. So that gives us AH is positive 20. So it's definitely acting in that direction. So the forces in Y, 0. So we have our AV plus our DV minus 5 is equal to 0. And I think that's it. And so what that basically says is our AV plus our DV has to equal 5. So we're going to take a moment about any points. Point has to equal 0. Call clockwise moments positive. We're going to take them at A. So we have 3 times 5. So this guy, 3 and 5, that's a positive moment. And this is 3 and 20. That's a negative moment. 3 meters, 20 kilonewtons. And then we have a minus 6. Our dV, and all of that's equal to 0. So what this is going to give us is our dV. Get that moment. That'll give us negative 45, comes over as a positive 45, divided by a negative 6, gives me a negative 7.5, and that's actually acting down. So we plug that in here, minus 7.5, bring that guy over, and you notice that RAV is equal to, what do we have, 12 and a half. 12 and a half positive, that is acting up. So we made one mistake here, and we're going to go ahead and correct that before we get into this process of the joints. It's easier to do that than to try to flow through with negative values. And these are correct. So we'll just get rid of the unknowns and we'll replace them with values. So this guy's definitely acting down, and that's 7.5. So I've corrected it here, but I'm calling it positive. And this one is 12 and a half up. And this one is 20. So now we need to determine a good place to start, and A is probably good. D would probably be a good place, and potentially C. So they've got a couple different places, but I think we're gonna start at A first, and then we'll work our way around. Okay, we're gonna do a free body diagram at joint A and see if we can resolve this. So we have joint A. We have two reactions feeding into this. One here, which is 12.5, and one here, which is a reaction of 20 kilonewtons. If we look at this, then we have a diagonal and a horizontal member. So if we look at this, this guy has only vertical, so or horizontal rather, so there's no vertical. So the only thing this can do is counteract that vertical. So this guy definitely has to be acting down. So we're going to call this member AB, and I'm just going to go ahead and call this negatively acting as well, and we'll see what happens. Or a compression. So both of these we're saying are in compression. So we're going to go to sum of forces in X to equal 0. In the X we have 20 minus AB horizontal minus AC equal to 0. And basically we can just flip sides. So what we end up with is ADH plus AC is equal to 20, getting rid of the negatives. But that doesn't tell us a whole lot. Let's see what happens with the vertical. If we don't get a solution, we went to the wrong joint. Okay, so in the Y, we have 12.5 up minus AB vert has to equal 0. Therefore, AB vert is 12.5. So it's positive on both sides. So that's correct. Now the beauty on this one, again, this is a 45-90 triangle. So this is 3 meters by 3 meters. So knowing that, we can write an equation. AB horizontal is to 3 as 12.5. The vertical is to 3. And we'll notice is the 3's will cancel. Because it's 45-45, the sides are equal. You really don't even have to do that proof, but it's nice to do it. So plugging that back into here comes over. So we essentially are going to have 20 minus the 12.5. And what that gives us then is positive 7.5. Positive indicates compression, which we indicated. And since we have both components of AB, we can solve that through Pythagorean theorem. Squared plus 12.5 squared square root. So AB turns out to be 17.68, and that's compression. So that one resolves very, very nicely. Okay, so at this point, I look at this truss and I see there's a lot of different places I could probably go. I'm going to go to C because I think C is going to be a real simple solution, and I think you'll see this here. In fact, if you look at this by inspection, you can pretty much see what's going on. We did just solve this member. We solved that member as a compression member, and that's coming in compression at 7.5 kilonewtons. Nothing here external. So we just have this guy coming in, and it has to be compressing that way. So we're going to call that CD. And then we have a member here. I'm just going to arbitrarily call it up, and that's member CB. So this one, real nice. If we look at sum of forces in the X, we have CD minus 7.5 is equal to 0. CD, therefore, is 7.5. Positive indicates that it's compression, just as we indicated initially. If we look at sum of forces in Y, we have CB, and that's equal to 0. So that's very nice. And so this member is carrying no load, is what that's saying. When you look at that overall truss, you might think, well, that's, can't be really what's happening. But what you'll see is at the top, the two members that are diagonal are taking all the load, and this one is just really doing nothing. So we'll go now to the next location. So I'm going to go ahead and go up to joint B, where there's a lot of action going on. And let's see how this one comes out. So I have two external loads on this, and I always like to do my externals first. That way I don't forget them. Externals are reactions. I always do those first. So we have a 20 kilonewton external load and a 5 kilonewton. This guy we just resolved to be a nice 0. This guy we have coming in, we also resolved that. That turned out to be a compression member. So it's going to be compressing into this joint. And the horizontal and vertical components of that were 12.5. And since it's a 45-45, that's also 12.5. So we have one diagonal to solve here. It looks like a mess, but actually it's pretty simple. If we notice, we have 5 down, 12 up. So it looks like this guy's going to have to come down to counteract the difference. So I'm going to make this as a tension member. So we're going to call this BD. Put BD in tension. And I think we're going to get both the y and the x equations to resolve, and we'll see what happens to make sure that's right. So in the x, we have 12.5 minus 20 plus, it looks like BD horizontal, and that looks like that should be equal to 0. So what that resolves to, when you do the math and bring that over, you get BD horizontal is equal to 7.5 kilonewtons. And this number is also a 45-degree angle. So this has to have the vertical and horizontal have to be equal. So let's see what happens when we resolve this on the y. And if we get a negative value or we get a number other than 7.5, we've got a problem. So let's see what we've got. We have 12.5 up minus 5. And then we've got minus BD vert is equal to 0. So 5 minus 12.5 gives us 7.5. Positive comes over as a negative. Negative on both sides is the same thing as having a positive. So BD vert is also 7.5. Positive, positive, they're the same numbers, that agrees. And again, because it's a 45-45, you know it has to. So this one is a tension member. It's going to be 7.5 squared, 7.5 squared, square root. And that is going to give us 10.61. Nothing else to solve on that one. So we've got one more joint to do and everything should go to 0 at this point. So here's our last joint. It happens to be a reaction. This is the reaction at D, or the joint D with a reaction. So this reaction we modeled wrong initially, so it's actually going down. We corrected that, but make sure that you've got that right. And then we had a compression member here, and that's 7.5. And we just had a tension member going like this. And he has his two components up and over. And those were also 7.5, 7.5, like the numbers I see. On the X, we have 7.5, 7.5 equals 0. Yes. Sum of forces on the Y has to equal 0. We've got 7.5 up minus 7.5 also equals 0. So that was a nice truss. Had symmetry going on. It did have a reaction acting down, which is somewhat unusual, but you'll see sometimes. And so that one worked pretty well.